Okay, today we're going to talk about rational exponents. This is section 6.1. All right, the first section is we're going to write radicals in exponential form. So it shows you what rational exponents are. So the square root of 8 can be written as 8 to the 1.5 power. The square root of 30 can be written as 30 to the 1/5 power. The cubed root of 4 squared is 4 to the 2/3 power, and the sixth root of 7 cubed is 7 to the 3/6 power, and if you reduce it, that's 7 to the 1/2 power. Okay, so let's write some of these on our own. So you're going to notice that the numerator of the rational exponent is the power of the radicand, what's inside of the radical symbol, while the denominator is the root. Okay, so let's try some of these. 13, the square root of 13 is 13 to the 1/2 power. 4, fourth root of 3 cubed becomes 3 to the 3/4 power. The cubed root of 4 becomes 4 to the 1/3 power, and the sixth root of 90 squared becomes 90 to the 2/6 power, or 90 to the 1/3 power. Okay, so we're going to start solving equations using rational exponents. So the most important thing, and for now you're going to learn a different way later in higher level math, but for now you have to have the same base when you solve. Okay, so here in number 1 you have the base of 5s throughout. So you can simply get rid of the bases, cancel the bases out, and you have 2x to the third, or 2x over 3 times x over 6 equals 2. Now, you have to remember the rules of exponents. So when we're multiplying exponents with the same base, we're going to add them. So first of all, let's get the same denominator. So I'm going to make these both have a denominator of 6. Because we're adding them, we have to have the same denominator. So to do that, I'm going to multiply both the denominator and the numerator by 2. So I have 4x over 6. And remember, these are exponents. Even though I've canceled out the base, they're still exponents, all right? So I am going to add them. So I have 4x, and another x is 5x. And like I do with a fraction, I'm going to keep that 6. Now, I'm going to solve by dividing by 5/6, which is multiplying by the reciprocal. So I have x equals 2 over 1 times 6 over 5, and x is 12/5. Okay, stick with me here. So this time, again, we're going to get rid of all of the bases. As long as we have the same base, we can just go ahead and solve. Okay. So I have 4x plus 10 on this side of the equal sign. So if we remember, now these are exponents, keep that in mind, and when we divide exponents, we subtract them. So on this right side of the equal sign, since we canceled the bases, we're going to have 3x minus, and in parentheses, you're going to put negative 2x minus 4. So we're going to distribute that negative sign. So I have 3x plus 2x plus 14. Okay? So now I'm just going to solve. Simple as that. I'm going to gather those like terms on the right side. So I have 5x plus 14. I'm going to bring the variables to one side by subtracting 4x. 10 equals x plus 14. I'm going to subtract 14 from both sides, so x is negative 4. Take your time, go back and watch the example again if you need to. This is all uncharted territory. So let's try another one. Again, we have the same base. They all have the base of 12. So we can cancel out all those bases for now. All right? So this is division. So I'm going to take, remember these are exponents and we have to treat them like exponents. So we're dividing exponents. And when we divide them, we subtract. So I'm going to take 4x minus 1 minus the quantity of 2x plus 5, and then set that equal to 7 because we canceled the bases. We're going to distribute that negative sign, both those terms, and we're just going to go ahead and solve. We're going to combine these like terms over here. So I have 2x minus 6 equals 7. I'm going to add 6. So I have 2x equals 13. And when I divide by 2, x equals 13 halves. Okay, so we have the base of 9 for number 4. So remember, we're multiplying, which means we're adding the exponents. The rules for multiplying exponents is you add them. Oh, let me go back or forward. So here I'm going to take 3 plus 5x equals 13. I'm going to subtract 3 from each side. I have 5x equals 10. And x is 10 divided by 5, which is 2. Okay, so just when you thought you're getting it, now we come across problems that don't have the same base. What you can do is you can force them to have the same base. So this is 2. We can make 8 into having the base of 2. So 8 can be written as 2 times 2 times 2, which is 2 to the third. So let's rewrite this to be 2 to the third, but we're going to multiply it by what's already there. We have to take that into account. So when I cancel out the bases now, I have 6x plus 1 equals 3, quantity 3x minus 4. We're going to distribute that 3, and we're going to solve as normal. So I'm going to get my variables to one side. So I have 1 equals x minus 12. I'm going to add that 12 to each side and divide by 3. So x is 13 thirds. Okay? Let's go to 6. Again, somehow, we got to get everything to have the same base. So if you start looking for bases here, I looked at 3 because I know that 3 squared is 9. So 3 squared times 2x. So when I looked at 243, I figured out that 3 to the 5th is 243. Okay? So now I'm going to get rid of the bases. I have 2 times 2x equals 5, quantity x minus 11. 2 times 2x is 4x. 5 times x is 5x. 5 times negative 11 is negative 55. I'm going to subtract 5x from both sides, so that leaves me a negative x over here equals negative 55. Divide by negative 1, and we have x is 55. Once you get to that same base, this is something that we should all be familiar with. So I look at 16, and I see that 16 is a perfect square of 4 squared, but you cannot make 4 into 8. So I'm going to go even further. I know that 4 is a perfect square, and it's 2. So 2 to the 4th power is 16. I'm going to multiply it by the exponent that's already there. And then 2 to the 3rd power is 8. So now we have that same base that we can cancel out and just leave our exponent. This is a minus. So I have 4 times 4x is 16x. 4 times negative 5, negative 20. 3 times x is 3x. 3 times 3 is 9. Okay, so let's bring the x's to one side. So I have 13x minus 20 equals 9. Oh, this is an 8. Sorry, thought something was weird. This is 24. There we go. So now I'm going to add 20. So I have 13x equals 44. And I'm going to divide by 13. So x is 44 thirds. Okay. If you remember our rules of exponents, what kind of exponent makes a fraction? Well, that's a negative exponent. So these, when we make them into the same base, we're making them back to where you started, back to the negative exponent. So we know that 6 squared is 36. So this, to start with, was 6 to the negative 2nd power. And then we're going to multiply that times the 2x minus 6. And then we know that this was 6 to the negative 1st power before we made it into a fraction. So then we're going to multiply that by the exponent. Now we got the same base. So again, we're going to cancel out the base. And solve with what we have left. So I have negative 2 times 2x is negative 4x. Negative 2 times negative 6 is positive 12. Negative 1 times 9x is negative 9x. Negative 1 times negative 1, positive 1. I'm going to add this 4x to both sides. So I have 12 equals negative 5x plus 1. Subtract 1, so I have 11 equals negative 5x. Then I'm going to come up here and divide by negative 5. X is equal to negative 11 fifths. All right. I'm going to stop here, and then I'll see you in the next part.